So let's look at one more measure of spread today called standard deviation. Standard deviation is a typical distance between the individual data points and the mean. So we're going to look at the standard deviation of a couple of different data sets. To find the standard deviation, there's a few things we're going to do. We're going to find the mean of the data set. The mean is abbreviated x bar. Then we're going to find the difference between each value and the mean, which is calculated by taking each x value minus the mean, x minus x bar. We're going to square this difference, which we're going to call x minus x bar squared. We're going to add these differences and divide by n minus 1, and then we finally take the square root to find the standard deviation. So it's kind of a complicated explanation. The calculations aren't difficult to do, but it takes a little bit of time to kind of get that. So we're going to look at points scored by the Lions during the first 4 games. We're going to say they'll score 28 points, 16 points, 12 points, and 10 points. So the first step that we're going to do is we're going to find the mean of the data set. And the mean is found by adding these numbers together and dividing by 4. Let's do that first. So the mean I get is 16.5. Whatever you get, try not to round this number. I'm going to write this mean in each of the boxes that say x bar. Step 2, find the difference between each value in the mean. So we're going to subtract the x value in the first column minus the x bar value in the second column. So we'll do that next. Make sure if your value is negative that you write the answer as a negative number. Here, 16 minus 16.5 is negative 0.5. Make sure you include the negative there. Again, we're subtracting 12 minus 16.5. That's going to be negative 4.5. And a fun fact is that if you actually add your answers here, these answers should always add up to 0 if you've done this correctly. Third step, we're going to square each difference. So what we're going to do is we're going to take the numbers in the third column and we're going to square them. Again, do not round your answer. Remember, if you're squaring a negative number, be sure to put the number that's negative in parentheses before you square it. Your answer squared should never be negative. Your answer here should always be either 0 or a positive number. Again, make sure that you put negative 4.5 in parentheses. And again, we put negative 6.5 in parentheses before we square it. Step 4, add these differences and divide by n minus 1. So we're going to take these numbers in this fourth column and we're going to add them together. When we add these numbers together, we get 195. Again, if you got a decimal answer, do not round this. Then we're going to divide this by n minus 1. N is the number of values that we have in our list. We have 4 numbers in our list, so we're going to divide by 4 minus 1, or 3. So we're going to take 195 and divide it by 3. We got 65 as our answer. Again, if this was a decimal, don't round it. The last step, we're going to take the square root to find the standard deviation, so we're going to square root the 65. You can round this answer. This is our final answer. Our standard deviation is about 8.06. What this means is that typically, a lot of the numbers in our data set should be around 8.06 away from the mean. So our mean was about 16.5. Most of the numbers in this list should be within about 8 of the mean. So if you were to add 8 to 16.5, you would get 24.5. If you subtract 8 from this, you get about 8.5. Most numbers should be around 8.5 to 24.5 in our list. We're going to try example 2 now. We'll go a little bit quicker this time. I'm going to start by writing these numbers in our first column. Step 1, find the mean of the data set. We'll add these 5 numbers together and divide by 5 to find the mean. Once we add them together, we divide by 5. And our mean is 28.2. We'll write that number in the x bar column, and that's step 1. Step 2, find the difference between each value and the mean. We're going to take each of these x values and subtract the value in the second column, 28.2. Our first value is 16.8. Our second value is negative 5.2. Our second value is negative 14.2. Our fourth value is negative 1.2. And our last value is 3.8. Step 3, square each difference. We're going to take each number in the third column and we're going to square it. Our first value is 282.24. Our second value is positive 27.04. Our third value is positive 201.64. Our fourth value is 1.44. And our fifth value is 14.44. We've done step 3, square each difference. In step 4, we're going to add these 5 differences together, and then we'll eventually divide by n minus 1. The sum of these numbers is 526.8. We're going to divide by n minus 1. Our list has 5 numbers this time, so there's 5 numbers. N is 5. 5 minus 1 is 4. We're going to divide 526.8 by 4. And we get 131.7. Step 5, take the square root of this value. So we're going to take the square root of 131.7. And this number is your standard deviation, which is 11.476. We'll call it 11.48. So this means that typically a lot of numbers in the second list are within about 11 of 28. So if we were to subtract 11 from 28, we would get about 17. If we add it, we get about 39. So a lot of scores should be around 17 to 39. And you notice here, most of the scores are. One score got a little bit higher, but this gives us kind of typically where the values are. Which of these examples feature the larger standard deviation? Well, when we compare these two numbers, it's pretty clear that example 2 does. Why does example 2 have a larger standard deviation? Well, standard deviation is a measure of spread, which tells us how far apart the points are spread apart. And you can see in the first game, if you were to even compare the first value and the last value in this list, the biggest spread of scores that we have is 18 points between these numbers. If we look at the highest and lowest scoring games here, we're going to notice that difference is 31. These numbers seem to be a lot more spread apart than these do, so we would expect the second example to have a larger standard deviation. The points in general seem to be more further spread apart. The last thing we're going to talk about today is variance. And the variance is the square of the standard deviation. It's essentially what we get before we do the square root step. Variance is used in the field of statistics quite a bit. However, what's kind of odd is it typically doesn't have any real-world significance. The units for variance are the square of the units for standard deviation. So if you got a standard deviation, for example, of 3.6 miles, we would say the variance would be 12.96 square miles. While there are places in math where we do work with square miles, variance gets more challenging to explain when the units for standard deviation are in dollars, for instance. So I say square dollars, what does that mean? Even in this example here with points, if we squared these numbers, what we would get would be something like squared points. What does that mean? Well, in the first example, if you were to take 8.06 and square it, what you would get would be the number pretty close to 65 here. This is the number that we square rooted to get 8.6. So for example 1, the step that we'd get before square rooting is the variance. That's this number here. If I were to say what are the units for it, standard deviations have a unit that's the same as what we're working with. So the standard deviation for our examples here would be in points. So officially, the variance here would be 65 square points. And I know that's kind of strange, but that's officially what it is. In the other example, before we did the square rooting step, we got 131.7. That's your variance for example 2. So this number is the variance. And the units for this would also be square points, which is kind of interesting. Anyway, today's focus today was looking at different measures of spread. So today we looked at how you calculate values like interquartile range, standard deviation, and variance.